Hi friends, welcome back. This is Devang here. We had been doing revision of the subject of EIS, Enterprise Information System. Chapter number 3 is what we did in the previous lecture. Previous lecture was lecture number 1. We did chapter number 3 in that. This is my lecture number 2. Here we'll be starting with chapter number 4. Chapter number 4, which is e-commerce and emerging technologies. Chapter 4, e-commerce and emerging technologies. Now this chapter, as per the name, has coverage of two things: e-commerce and emerging technologies. When we had learnt the chapter, you had all these topics in the chapter, out of which, say, these first 7 topics I had covered under the part of e-commerce, and the last one, emerging technologies, was the second part. So I split the chapter in two parts. One is e-commerce and other is emerging technologies. Yes, now e-commerce, emerging technologies. Emerging technologies is the more important part. E-commerce is, well, a little less important part. Now, under e-commerce, we learned all these topics here. Acha. Before I go on, let me remind you, these sessions are your revision sessions. Revision, as in, I request you to see these videos only after you are done with the subject, only after you have seen all my regular classes, either attended my regular classes or seen my online pen drive classes completely. This is simply for revision. I'm planning this revision under 5 sessions, one session for each chapter. Chapter 3 we did last time. This session is for chapter number 4. Okay, now for e-commerce, first topic here is just basic introduction. What is e-commerce? E-commerce means what? E-commerce means any commercial activity through the internet. Any commercial activity through the internet. So the first discussion in the chapter was comparison between traditional commerce and e-commerce. Traditional commerce means you go to the shop and purchase the products that you want. E-commerce was commercial activity through the internet, either online shopping or online banking, or maybe even online filing of forms, filing of returns, and all that we had covered under e-commerce. Yeah. Anyways, that part I'm not revising, that you have to read on your own. Next was benefits of e-commerce. Benefits of e-commerce, we had discussed various examples in that. In general, it was benefits to the customer, benefits to the seller, and also benefits to the government. All these benefits are given in your book. You give it one reading, and I do not expect you to memorize all these benefits. You just need to give it one reading and you can make your own answers there. Yeah. The important part we start here with is e-commerce business models. Business models over here are basically different types of business that can happen in e-commerce. Different types of business that can happen in e-commerce. Types, as in, say, there can be various different types, a long list given. We'll discuss each of them. E-shops. Now, e-shop is basically the e-commerce which is run by a manufacturer, where manufacturer will sell his products directly online. For example, Samsung selling Samsung phones on the Samsung website, that becomes e-shop. It is not Amazon, because Amazon themselves are not manufacturers. So e-shop is a virtual storefront that will sell products and services online. It will allow manufacturers to bypass the intermediate operators. Yeah. E-malls. Well, e-mall is conglomeration of different shops. Now this is where Amazon, Flipkart can come. It is conglomeration of various sellers together. Yeah. E-auction. Now e-auction is basically an auctioning website. Auctioning website where e-auction, electronic auction, provides a channel of communication through which bidding process for products and services can take place between competing buyers. Buyers will compete directly online. So it is like an auctioning service started online. So going further, after e-auctions, portals. Portals are basically what? Portals are websites. Portals are the websites through which other websites are offered as content, so that and a company who wants to get customers, they will put their website on the portal. The portal will be charging the company for advertisement and will be charging customers a subscription fee. Yeah. Buyer aggregators are the website who will bring together individual buyers. It will bring together large number of buyers and they collect information about the sellers and sell them on their website under its own brand, like say Ola Cabs. Ola Cabs is bringing together various customers who want cab services, that is the buyers, and they also brought together various cab owners, and now they are providing cab services to the customers under its own brand name Ola. Yeah, that is buyer aggregators. Virtual community is a community of customers who share a common interest, so they can make discussions, they can answer questions of each other, they talk about a wide range of subjects. Yeah. E-marketing means marketing through the internet. Yes, e-commerce is also used for marketing and using the internet to achieve marketing objectives. Information on website will also empower the customers, because now customers have better knowledge. In fact, customers and the sellers both have better knowledge of the market, so the internet changes relationship between buyer and the seller, because market information is now available to all parties in the transaction. Yeah. E-procurement is procurement, like purchasing through the internet. Efficiency, it brings efficiency in accessing information on the suppliers. You can get information of suppliers here, availability, price, quality of the product, delivery times, all the things you can get directly from the e-procurement portals. E-distribution is used by the distributors for managing large number of customers that they have, automating orders, communicating with partners, etc., order tracking and all. In short, it is used by the distributors. All these different models of e-commerce can be classified under these three categories here: B2C, business to consumer, business to business, and consumer to consumer. Next, components of e-commerce. Components of e-commerce are basically things that are needed in order to set up e-commerce business, things that are needed to establish e-commerce. Well, naturally, user is needed. User is the customer who wishes to make purchase from e-commerce. E-commerce vendor is the seller on e-commerce. Amazon, Flipkart, all these are your e-commerce vendors. Now, e-commerce vendor needs to ensure certain things. They need to ensure the following things. So these are the list of things that the vendor should manage. Vendor should ensure supply chain. They should create a proper supply chain, ensure that the products are delivered to the customer in as much short time as possible. Warehouse operations, the vendor will also have a warehouse and he needs to have proper operations in the warehouse. He might even think of doing automation in the warehouse. Vendor has to ensure shipping and returns should be fast enough to the customers. Vendor should have proper display of all products on his website. They will also have loyalty programs, like you keep purchasing from the same vendor, then you get some loyalty benefits, you get some cashbacks and points and all. Nowadays, many vendors have also set up their own physical showrooms. Yes, online e-commerce vendors setting up physical showrooms, so that they can give the customer a feel of the product, a first-hand feel of the product. Vendors offer different ordering methods like cash on delivery, card on delivery and all. They provide guarantees for the products that they sell. Privacy policy. Vendors should also have a privacy policy which will declare that the vendor will not leak the privacy data of the customer to outsiders. Look, Amazon, Flipkart and all, they have lots of data about you. They have lots of data about the customer, but their privacy policy ensures that they will not release your private data to any unauthorized people. Security, they have to ensure security of the transmissions. SSL is a method of encryption which they use to ensure secure transmission of payment information. Technology. Well, another component needed is technology. Various technology are needed for setting up the e-commerce, like computers, servers, database are needed. Naturally, e-commerce network will contain many computers, many servers, database and all. They store the data, program. They also use cloud computing for that matter. Mobile apps. Well, they also use mobile apps. Nowadays, customer accesses e-commerce more from the mobile app rather than from a laptop. Mobile they carry everywhere, laptop they don't carry everywhere. Yeah, so mobile app is a software application that is specifically designed to run on a mobile. But developing mobile app might become expensive for the vendor. Developing mobile app might turn out to be expensive for the vendor. Why? Because if they develop mobile app, they'll have to develop separate mobile app for each platform like OS. Say I'm using Android phone, they'll have to develop separate mobile app for Android phone, separate mobile app for iPhones and all. That makes it expensive. Instead, certain vendors, what they might do is they have another option that instead of creating mobile app, they'll just create a mobile website which is mobile friendly. So now either Android phone or iPhone, both of them can access the same website through their respective website browsers. Also, in case of these mobile apps, that mobile app should also include the following. It should contain data about all commodities and services that are provided by the seller compiled in proper catalogs. Well, mobile apps can also offer various vouchers and coupons to attract customers to purchase from the mobile. Mobile advertising is very famous nowadays. Like advertising is more convenient through the mobile app. Mobile customer support directly given on the mobile banking also most of the e-commerce have now started doing. Digital library is also a part of technology needed. Digital library is collection of digital objects like text, images, audio, video, collection of text, collection of images. You're watching my videos on the YouTube channel, on my YouTube channel. What is YouTube? YouTube is a digital library. It is a collection of videos on the internet. Yes, that is also required for e-commerce. And data interchange, EDI, electronic data interchange. Data interchange is an electronic communication of data. For example, if I am a manufacturer, I need some materials. My material supplier is a different company. Now, that supplier and my company will have an EDI in between. EDI is basically an integration, such that my software is integrated with that supplier software, such that whenever the material stock in my company goes below the reorder level, then my software will automatically generate a purchase order, send it to the supplier company, and the supplier company software will automatically process my purchase order and deliver the products to me, deliver the material to me. This is basically like an automated purchase, automatic purchases. These automatic purchases are basically an example for EDI. Yeah. Other components needed, internet is needed, definitely web portal matlab website is needed, and payment gateways are needed for secured encrypted payment transmissions. All these are the components needed for e-commerce. Further, architecture of networked systems. Well, remember we had learnt about client server network, where server provides the service of searching a particular data, sending that data to the client. Now, such client server networks can be of two types: 2-tier architecture or 3-tier architecture. Listen to the difference. 2-tier architecture was the architecture where there is just one server and all others are the clients. So in case of 2-tier architecture, there is no second server. There is one server and all the others are the clients. Clients are responsible for presentation. It is called as presentation tier, while server does the storage. Storage of what? Storage of the database. Yes, so that was your 2-tier architecture. While in case of 3-tier architecture, if I require certain apps, I need softwares like taxation software, auditing software, accounting software, then if all these softwares are put in that same server, then this server will get overloaded. Now, to prevent the server from getting overloaded, what we did was we created another server connected to the same network. So now you see that in my network here, there are two servers in the same network and all others are the clients. Now in the same network, I have two servers and rest all clients, meaning these clients will do what? They will still do presentation work. Server 1 is my database server. It will still store the database, but server 2 is called as application server. New server 2 was application server. It stores what? It stores all the apps. All the apps are stored in the server 2, that is your application server. And remember, the client can never directly access the database. Clients can access the database only through the applications. Applications are there in the application server. For example, if computer C2 wishes to see the accounting data, can computer C2 see the accounting data here? No. Rather, computer C2 will access the accounting software. Accounting software will get data from the database, show it to the client. This is how your application server works. Now, application server provides these apps, so all the processing is done in the application server. Accounting work is done by the application server. Tax calculations is done here. Auditing work is also done over here. Now, for that matter, these apps need to access this database. Now, if these three different apps want to access the same database, well, you remember a concept called as API. When three different programs wanted to access the same CPU, I had discussed an API in between. Remember, at that time, who provided API? Well, at that time, if you remember, API was provided by the operating system. When three programs wanted to access the same CPU, then operating system provided API in between. Same way, over here, when three different softwares want to access the same database, then also an API is required in between. Because how can tax software access the same data as accounting software, auditing software? Well, it is possible due to API. Now that the API is created, where is this API created? API exists in the database server. So this database server provides API, because of which any app can access the same database. Even new softwares, when you have to create, when the programmer needs to create a new software, he does not need to know that how is the data stored. He does not need to know the actual method of storage. He just needs to know what is the API here. Yes, that creates independence, data independence. Yeah, data independence is one of the main features of the three-tier architecture. See that? Two-tier architecture, you have presentation tier, database tier. Presentation tier is the client, which is the interface, matlab screen shown to the user interface. Database tier is the one where the data are kept. While in case of three-tier architecture, there is still presentation tier, there is still database tier, but the new one was the application tier. Application tier does what? Performs the processing. Because apps are located in the application tier, it will do the processing. And you see here that client can never directly access the database. They'll access the application server from which they can access the database. So the database tier is the one where the data is kept, and it is independent of the application server. It provides, database tier provides an API because of which it can avoid dependency on the storage mechanism. This is what I told you. Because of the API, the programmer does not need to know that how do you actually store the data. It avoids dependency on the storage mechanism. Programmer just needs to know that what is the API. Yeah. So that was your three-tier architecture. Then next few things you can read yourself. I am not revising. Going further to risk and controls. Now risk and controls are basically covered in almost every chapter. In this chapter, we cover risk and controls regarding e-commerce. Certain risk factors are general risk items like hacking, quality issues. Customer might doubt the quality of the products that he gets. Customer might have risk regarding delay of delivery of the products. Customer needs internet, so there is lack of personal touch. Possibility of the credit card frauds, cloning of credit cards and all. Also, you require infrastructure of roads and railways and all. These are the general risk items here. These were mostly the general risk factors. But the next ones after that, which I give you here, are more technical, more specific risk factors. So listen carefully. These are a little more technical. Plus, these are now the risk factors which are mostly from the viewpoint of the e-commerce seller. That e-commerce seller has the risk of anonymity. Anonymous buyers. Well, generally, they will never sell a product to the customer without getting all details of the customer. They will ask you to log in only after that the products will be sold to you. So that is like anonymous buyers are not allowed to buy. Repudiation. The word repudiate means to deny. Repudiation is the possibility that the transaction may be denied by the person. Lack of authenticity of transactions, yes, because it is all e-commerce. Data loss, hacking, denial of service. Denial of service is basically server down problem. Yes, these are certain common problems that might happen. Non-recognition of electronic transactions in the court of law. Well, maybe in certain legal battles you might not be able to prove the e-commerce transaction, or electronic transaction might not be considered as a proof of law. Lack of audit trail. Well, when everything is done electronically, there is no physical documents involved. If there are no physical documents, what will the auditor check? Like there is no purchase order, there is no actual document of purchase order, no purchase invoice, no payment confirmation, no PRN, no GRN and all. If none of the documents actually exist, everything is done electronically, then there is lack of audit trail. Yeah. Problem of piracy. Piracy is basically using somebody else's content, using the copyright protected content of someone else. Like you download pirated movies, you download pirated softwares and all that is basically a violation of law, and that is a big problem in e-commerce right now. Further, control measures. Well, within controls, first we discuss who needs to implement control. All the persons who need to implement control. Users will implement control. User need to ensure that he is genuine and he is not hacked. Seller, buyer, merchants should ensure that the product catalogs are properly put on the website. Price catalogs are properly put. Discount schemes are not misused by the buyers and all. Product returns are properly handled and all. These are the things that the buyer, seller, merchants should ensure. Government has to ensure that tax accounting is done correctly, that e-commerce vendors are not doing tax evasion in e-commerce. Government should ensure that all the products sold on e-commerce are legal. Illegal products are not sold through e-commerce. Network provider is like my internet service provider. He needs to ensure availability and security of the network. Technology service providers are like the cloud computing, other service providers like cloud computing. What is cloud computing? We'll see later in the chapter. Logistics provider are the transport operators. Payment gateways also need to ensure their own securities and all. Which controls needs to be put? Well, educating the user regarding what to do, what not to do. Communicating policies to the customer. Like Amazon should communicate the policies to the customer clearly, so that later the customer does not blame Amazon that you didn't tell. Yeah. So communicating policies to the customer, privacy policy, shipping policy, information security, refund policies should be properly communicated. You should follow the laws of the land properly and protect e-commerce business from virus, hackers, etc. These are the controls that must be implemented. Control objectives are basically why should I implement controls, and that is repetition from chapter number 3 that you can revise. Further, guidelines and laws governing e-commerce. Guidelines and laws governing e-commerce. Well, guidelines over here are basically internal guidelines of the company. Every e-commerce company should have their own internal guidelines. Guidelines regarding how will they do the billing. Guidelines regarding what will be the policies regarding guarantees and warranties. What will be the shipping policy. What will be the delivery methods and all. All such things should be mentioned in the company internal guidelines. Plus, these guidelines should also be communicated to the customer, because if my company has a no return policy, it should be communicated to the customer. Otherwise later the customer might come fighting. Yeah, so all these guidelines companies should make and should be conveyed to the relevant people properly. Various laws are also applicable to e-commerce companies. E-commerce companies need to follow all these laws and regulations and all. Well, you're not given provisions of these laws, you're just given the names of the act. You just need to go through those names. Only one of the law you're given provisions within, that is Foreign Exchange Management Act, Fema. Now Foreign Exchange Management Act, this act talks about FDI. FDI means foreign direct investment. Like if a foreign company wants to invest in e-commerce in India, foreign company can invest in e-commerce in India as per the Fema rules. Look, Fema does not contain rules only regarding investment in e-commerce. Fema contains rules regarding foreign company making any investment in India. You are learning here only the rules regarding investment in e-commerce business. Yes, so foreign company can do e-commerce business in India if these three conditions are fulfilled. If either of the three conditions are fulfilled, say if the foreign company is a manufacturer, he is permitted to sell products manufactured in India through e-commerce retail. So foreign company is a manufacturer, but he needs to set up a factory in India if he wants to do e-commerce retail in India. Or single brand retail trading entity, not manufacturing. Single brand retail trading entity can do e-commerce in India if they have physical stores also in India. And Indian manufacturer is permitted to sell own single brand products through e-commerce retail, where Indian manufacturer would be the investee company, meaning foreign company has made investment in Indian manufacturer such that uh, is the investee company which is the owner of the Indian brand is also Indian, and which manufactures in India at least 70% of the products in-house. Maximum only 30% it will source from outside Indian manufacturers. Then this guy is called as Indian manufacturer, and if the foreign company does investment in such Indian manufacturer, then they can do e-commerce in India. Yeah, these were your provisions of the FEMA. Consumer Protection Act, RBI Act, all these are also the legal provisions applicable to e-commerce companies. Further, last part in the first part of the chapter, that is e-commerce part. Digital payments, various different examples of payment methods are given. UPI payments is one of the most recent and as of now the most convenient payment methods possible. UPI apps are available. You can use the UPI app to directly transfer payment from your bank account to my bank account if you wish to transfer. So that is UPI apps. You might have used UPI apps. In fact, pen drive students, you might be using UPI apps pretty often because payments that you do on the website can also be done through UPI. IMPS is immediate payment service. It is like the next version of RTGS NEFT. It is like immediate payment can happen from my account to your account again. Beam is basically a mobile app made by the government of India, made by NCPI, National Payments Corporation of India, and it is basically a UPI app. It is a type or example of UPI app which generally nobody uses because there are better UPI apps. The best UPI app nowadays people use, that I am also using, that I think most of us Indians are using, that is Google Pay. Google Pay has clearly created a wonderful app and very convenient payment systems there. That is also an example of UPI. Other enabled payment services, well, government has also started payment services directly linked with your Aadhaar number. So I can make payment to you directly based on your Aadhaar number. I don't need to know your bank account number. But still it is not very famous because again, thanks to Google Pay has made it possible to make payment to you just by knowing your phone number. I don't need to know your bank number. I don't need to know your UPI ID. I don't need to know your Aadhaar number also. I just need your mobile number. Ussd was payment services, UPI services, kind of payment or mobile digital payment services without using internet. You just need to dial *999# from your phone and you will get an entire list of menu items and all. Last time when I had taught you this, I told you that you can try that in your phones after the class. Hopefully you have tried. You might have seen what does *999# do on your phone. And you don't need a smartphone for that. You don't need internet connection for that. Traditional methods of digital payment, e-wallet is like Paytm, Freecharge, and all these were your wallet payments. Cards, credit card, debit cards, net banking, NEFT, RTGS, these were all your different methods of payment. Yeah, all that. Well, with all that, that covers our topic regarding e-commerce. Next, we'll be talking about emerging technologies. Now, under emerging technologies, we are learning various different new technologies that are discussed in your book. Out of these new technologies, the first three were the more important ones. First three, if I show you them, just the headings first, the first three new technologies were important. Number one was virtualization. Number one was virtualization, second was cloud computing later, and the third one, second one was grid computing, and the third one cloud computing. Now these three technologies were the more important ones. The rest of them were less important, but to understand them, first I had given you some general example over here. For that general example for these technologies, first you need to understand what is a data center. Remember, what was data center? Data center is the physical location in which large amounts of data are stored. For example, if Google is giving 15 GB storage space to you, me, to everyone, so Google must be having such a huge storage space. Say Google has its data center here, then in this data center they have created 50 million GB of storage space. Remember, data center was the physical location which contains large amounts of data. It is like one very huge hard disk. It might be one entire building filled with hard disks, or it might be an entire campus filled with hard disks. That place, that building which contains lots of hard disks interconnected to each other, that creates 50 million GB of storage space. That can become an example of data center. Not necessary it is always 50 million GB. It can be many more, much larger data center. This is a very small example here. Anyways, so Google is actually into the business of creating data centers and giving it on rent. Google is into the business of creating data centers and giving it on rent. Google has created, say, this data center, in which it has given, say, in this data center 10 million GB space. Google has given to SBI to create its VPN, virtual private network, for putting its data. ICAI also wants to put the website data. 5 million GB is given to ICAI. 15 million GB is used for the users of Google, that is for Google Drive, and another remaining 20 million GB Google is using for its own data, their own accounting, their own employee attendance data, employee salary data, and all that comes in my data in the Google data center here. So data center is the physical location wherein large amounts of data are stored. Now they will be charging SBI, ICAI for storing the data. They'll also charge the user to store data in Google Drive. Up to 15 GB it is free. Beyond that they will charge whatever. So they are using the data center to provide storage space to other companies and charging them money for that purpose. Yeah. Anyways, this was basically the meaning of data center. Now for virtualization, I gave you two examples. Virtualization, the word virtual is basically artificial, and the concept of virtualization is always referring to the concept where you try to fool someone. Remember virtual memory, remember virtual private network. In all cases you are trying to fool someone. So in general, virtualization means to fool someone. Here in the topic of virtualization, I give you two important sentences. First one, I say that virtualization involves that one large physical network. The word physical means actual, real, not artificial. One large physical network exists, but it is converted into multiple small virtual networks. The word virtual means artificial. Virtual is what the user will see. So one large actual network is converted into many small virtual networks. So user, you will feel as if you are accessing three different networks, but actually it might be coming from the same location. This is the example which I showed you here. You are the user. You are using Google Drive, ICAI and SBI website. You feel that you are accessing three different websites at a time, but you never know. You might never know that all the three things are actually coming from the same data center. Yes. So virtualization, first example is that one large physical network, one large data center is shown to the user as if it is three different websites. That is my first example. That's the same thing I've written here. Multiple website in one Google data center is my example there. While second example also we have discussed, I say multiple physical network. Multiple physical network. Physical means actual, real. So in reality there are multiple networks, many small networks, but user will see as if it is one large network. User will see as if it is one large virtual network. Remember, virtual means what the user will see. So physically there are multiple networks, but what the user will see is that it is one large virtual network. For example, Google search. Remember my example here. When you perform a Google search, when you search something on Google, you are just typing the search words. and the Google server will search those words and give you the answer within like a fraction of seconds. Now, do you think that one Google server is searching the entire internet and giving you the result? No. Actually, when I do the search, then the search words go to Google India server. Google India server will share these words with various other Google servers, Google UK, US, Japan, Germany servers and all these Google servers will search in their respective areas. All these Google servers will search in their respective areas and give the search results to the customer. So they will search in the respective areas and they will send the search result to Google India server. Google India server will compile all the search results and give the result on your screen. You will feel as if the search was done by one Google server, but in reality the search was done by 10 different Google search engines. Yes, so you will feel that the search was done by one large Google server, but actually the search was actually done by multiple Google servers who were working in coordination. This is also virtualization. Now these two sentences give you an idea that what exactly is virtualization. Virtualization means to fool someone. To fool someone to believe something that does not actually in reality exist. Yeah. So in general, virtualization means to fool someone. It is to create a virtual version of a device or a resource. Example, there can be virtual server, like the second case, virtual storage, virtual network, virtual operating system. Virtual server was this example that actually there are 10 different Google servers, but what appears here is one large virtual server. So that is virtual server. Virtual storage. Well, when I store data on Google Drive, I feel that the data is in Google server, but in reality, what might happen is that Google might have stored my data in two different Google servers. Maybe some of my Google Drive data is lying in data center 1, some of my data is lying in data center 2. So even if the storage is at two different locations, even then, when I open my Google Drive, I will see all the things together. So user will feel as if it is one storage. In reality, it is physically in two separate places. Yes, that becomes my storage virtualization. Network virtualization is VPN, virtual private network, creating virtual network, artificial network. And virtual operating system. Yes, operating system can also involve virtualization. Generally, one computer system contains one operating system software, if you remember. Now, one computer system generally contains only one operating system because operating system is a master control program. It manages everything in the computer. But in little more advanced way, I can tell you that it is even possible that in one computer system, I install more than one operating system. Two operating systems, say maybe. Yes, it is possible. How is it done? It is done by virtualization. Now, if there are two operating systems in one computer, meaning both the operating systems will operate the CPU and RAM. Wouldn't they fight? No, there will not be any fight, there will not be conflict because virtualization ensures that it will fool both the operating systems. Even though your computer contains only one CPU and one RAM, physically it contains only one CPU and one RAM, but because of virtualization, both the operating systems will believe that they have their own CPU and they have their own separate RAM. Each of the operating system believes that it has its own separate CPU, own separate RAM. That is virtualization for operating system. So these were certain examples of virtualization. Further, virtualization allows its users to manipulate the system's operating system into thinking that a group of server is a single pool, or you can also run multiple operating systems simultaneously on a single machine. That is what we discussed. Even the concept of partitioning. Hard disk has partitions, C drive, D drive, E drive. That partitioning of the hard disk is also a type of virtualization because actually your computer contains only one hard disk. But virtually You can split that into 4 different or 3 different parts called as partitions, hard disk partitions. Example, partitioning of the hard disk is also an example of virtualization. Well, further, application areas of virtualization. Virtualization is used for what? Server consolidation is the example I gave. 10 different Google servers consolidated together to appear as if it is one strong, powerful server. That is server consolidation. Disaster recovery. Well, I'd given you example of SBI here. That if Google has SBI data in data center 1, Google also has SBI backup in data center 2. Now, the moment if there is any problem in data center 1, say if there is fire breaking out in a data center 1, then all communications from data center 1 will stop. Even then, an employee sitting in the SBI branch will not even come to know, because the moment the transmission stop from data center 1, immediately the transmission can continue from data center 2. This is called as disaster recovery. Because of such virtualization, employee here doesn't even come to know that data is coming from here or here. So because of this virtualization, you get disaster recovery. Virtual machines can be used as hot standby. Hot means ready, standby means a backup. So that data center 2 is used as a ready standby, ready backup. Virtualization is also used in testing and training. It is used as for portable applications. Portable means movable. Your applications can be run from any location, because of which even workspaces have become portable. Portable workspaces are also possible. Types of virtualization: hardware virtualization, where you create artificial hardware, creating a virtual hardware. Examples over here can be like, say, virtual memory was our hardware virtualization, virtual memory that we had learnt earlier. Also, several operating systems running in the same computer. More than one operating system in one computer is also an example of hardware virtualization. Why hardware? Because each operating system will be believing that it has its own CPU and own memory. Memory matlab RAM and other components. Each operating system believes that it has its own CPU. So if I have 2 operating systems in one computer, then both operating systems feel that they have their own separate CPU. One is real, one is virtual. Network virtualization is using virtualization concept to create a network. Example, VPN. But the words over here, I'll give you examples for that. Dekho. Network virtualization is a method of combining available resources in a network by splitting up the available bandwidth into channels, each of which is independent of the others, each of which can be assigned to a particular server or device in real time. Like for example, in case of VPN, my Ahmedabad branch and Bangalore branch were connected. My Ahmedabad branch, Bangalore branch were connected through the internet. So because of that, the internet bandwidth is split. General internet is different and my network on the internet is different. That is splitting the bandwidth. Yeah. So splitting the available bandwidth for creating my own private network in between. That was one example. Also, this allows large physical network to be provisioned into multiple small logical networks. We saw that earlier. Or multiple physical networks to be combined into large logical, that is virtual network. These were the examples I gave you earlier. Next, storage virtualization. Storage virtualization is the one where I give you example that my data is stored on Google Drive, but physically it might exist at 2 different places. So storage virtualization will pool data from multiple storage devices. Storage virtualization will bring together data from data center 1, data center 2 and make it appear as if it is a single device. Yeah, it will pool data from multiple storage devices into one single device. User isn't even aware that where the data really is. As a user, you will not even know that where is the data actually coming from. That was storage virtualization. In short, all that were the things under virtualization. Next, we talk about grid computing. Grid computing was a very advanced way of creating a network in which Each of the computer's resources are shared with every other computer. Remember, the main concept behind grid computing was that not only my data is shared, not only my programs are shared, but all my resources are shared with other computers on the network. That was called as grid computing. Each of the resources. Now, what resources can be shared? Maybe CPU is shared, that is processing power shared, or memory, RAM can be shared, hard disk can be shared. So grid computing was basically sharing resources with other computers. Look, in case of client server network, only server is sharing processing with other computers. In case of grid computing, each computer is sharing resources with every other computer. Look at the words. Each computer is sharing resources with every other computer. These words should come in your answer. Each computer will be sharing resources with every other computer. In the ideal grid computing system, every resource is shared, turning a computer network into a powerful supercomputer. Look, I'll give you example. I had given you example like this here, that if I have 1000 transactions to process on C2, then C2 will share these transactions with 4 other computers. It can share that transactions. It can share 1000 transactions with 4 other computers by using the idle processing capacity of each of them. Say at this point of time, if C1, C5, C4, C3 are sitting idle, then C2 will share the transactions with the other 4. C2 will say that 200 transactions are given to C3, 200 to C4, 200 to C5, 200 to C1, and 200 it will keep for itself. All the 5 computers will process their 200 transactions, and output is given back to C2. C2 will then present the output to the employee. Now imagine the employee sitting over here will feel as if that this employee will feel that his computer has become 5 times faster. In reality, it has not become 5 times faster. Rather, the processing is actually done by 5 computers. That is the main beauty of grid computing. Because of grid computing, your processing speed can massively increase because you can share processing power of all the idle computers on your network. Now imagine, here I had a network of 5 computers. If it is a network of 500, 5000 computers, then out of that, say 500 computers, at a time, maybe all computers processing power is not idle. But at this moment, at this very moment, if there are 100 other computers who are sitting idle, then my processing speed can become 100 times faster using grid computing. That is the main benefit here. Yeah. So benefits of grid computing is mainly making use of unused resources, resource balancing. Some resources are used too much, some resources are sitting idle. Because of grid computing, there will be balanced utilization of the resources. Parallel processing, collaboration, other resources can be utilized and all. Okay. Types of resources. What all resources can be shared? Well, main example that I gave was computation, that is processing power is shared. Now processing power can be shared in different ways. Like the example which I gave was the third one, that when an application is to be executed many times, 1000 transactions I had to process, then I will share the transactions with other computers. 200, 200, 200, each of them were processing. That was my third case here. But other two, say second one, said that to use application designed to split its work. Say for that 1000 transactions, I had to calculate salary and tax. Then what I might do is, all the salary calculations of 1000 transactions is done by my computer, while all 1000 tax calculation, all 1000 tax calculations are given to the grid. That is like splitting the app work. Or I can run the entire app on the grid, meaning my computer will neither calculate salary nor calculate tax for none of the transactions. All the work is given to the grid. That is like entire app is transferred to the grid. That can be my different methods of sharing the processing power. Sharing the storage. Each machine who has unused storage capacity will provide some storage to the grid. Communication. Well, redundant communication path. If there are more than one communication path in your network, then they can also share the communication path. Say internet connection is given through the server, but even C1 has its own internet connection. When the server internet connection is overloaded, C1 can offer internet services to other computers. That is redundant communication path. Another communication path is available. Software licenses. I'd given an example regarding Netflix. Like if I want to use Netflix along with 4 of my friends, then I can purchase one Netflix subscription, and this one Netflix subscription is shared with all my friends. And purchase one Netflix subscription and share it with all my friends, such that software Netflix is installed on all the machines, but it will limit the number of simultaneous user. So I can install Netflix on all our 4 mobile phones, but I can use it on only one of the phone at a time, because we are sharing the license among 4 of us. That is sharing the software and licenses. Sharing equipment, any other equipments can also be shared. That were the things that you can share on grid computing. Further, grid computing security that you can read. Next most important thing was cloud computing. Cloud computing was what? In general, cloud computing means various services on the internet. Internet providing Cloud computing means that internet is providing me various services, so that I don't need my own resources for that. Rather, I use resources on the internet. I use resources on the internet instead of using my own resources. That was basically cloud computing. Just a moment. Sorry for that. So cloud computing is basically various services on the internet. Services like storage on the internet, or maybe even processing on the internet. The most common use of cloud computing that you might have known was storage on the internet. But I made you realize that for companies, industries and all, the most beneficial use of cloud computing is software on the internet, not storage on the internet. Yeah. Anyways, cloud refers to applications, that is softwares, services and even storage on the internet, so that you don't need to use your own softwares, you don't need to use your own CPU, you don't need to use your own hard disk for storage. Instead, you do the storage on the internet. That was your cloud computing. Now think, if I do storage on the internet on Google Drive, where does that data, where does all that data go? Now you know, whatever I store on the Google Drive, where does that data go? Well, that data goes to this data center here. Whatever I store on the internet, that data goes to this data center. Yeah. Anyways, so cloud computing is basically storage on the internet or various services on the internet. User can access resources on the internet. User can access resources via internet from anywhere. These are the benefits. Location of the physical resource is not important. Applications are also directly on the cloud. Softwares on the cloud. Anyways, characteristics of cloud computing. One of the major advantage of cloud computing was this, that you use only what you need and you pay only for what you use. Remember these points here, these words, this paragraph here contains the words that should definitely come in your answer. Cloud computing can scale up to massively large capacities, and cloud computing will allow you to use only what you need and you pay for only what you use. Remember, I had given you example. If I set up my own data center, if I set up my own storage, then I will definitely create a storage which is much larger than what I need. But if I get storage on the internet, I will not create a storage. I will not purchase storage space very large on the internet. I will purchase only what I need, because later if I need more, I can anyways purchase more. Yeah. So I use only what I need and I pay for only what I use. These were the important words under cloud computing. Same words are further shown under the characteristics here. Elasticity and scalability. It is Cloud computing has the ability to expand or reduce resources. When you need more resource, you can expand, pay more, you'll get more. Pay per use, you pay for only what you use, only when you use it. On demand, whenever needed, you can demand more storage on the internet also. Resiliency, Google data center is more resilient. Resilient means it has the ability to face damages, or it has the ability to recover easily from the damages. It can completely isolate the failure of server and storage resources from the cloud user. Like that SBI disaster example. If there was a disaster in the Google data center, SBI employee doesn't even come to know that there was a disaster. This makes the SBI data center, this makes the Google data center more resilient, more reliable, in other words. Multi-tenancy. Multi-tenancy meaning that if Google is providing me storage space, Google is providing you storage space, does it mean that Google has separate hard disk for each one of us? No, they have one storage space which all the other users are sharing. In fact, same thing applies to applications also. I'd given you example regarding using software on the internet, and also shown you a video pertaining to cloud computing. So remember, in that video also it said that if I am using a software on the cloud, then the cloud software that I am using, I am not the only user of the software. There are many other users who are using the same software. So if I am using that same software, you are using that same software, then the software vendor does not have a separate copy of the software for each one of us. Rather, the software vendor has just one software which all of us are sharing. One software for which all of us are paying the rent. Basically, that creates a concept called as multi-tenancy. The same infrastructure is given on rent to many tenants, many users. Multiple users are using the same infrastructure. Generally, if I have one house, I can give it on rent to only one person. But in this case, if I have one infrastructure, I can give it on rent to thousands of people. All thousands are paying me rent for that, subscription for that. I hope you remember all that discussion we had done for software on the cloud. Workload movement, you can migrate workload across various servers because of the cloud and all. Okay, these were all the features and same things you'll find in the advantages of cloud computing. Please do revise that on your own. Further, cloud computing environment, types of cloud. Types of cloud, 4 different types I had given you. We'll have a fast revision for that. Private cloud is like a private data center. Private cloud is used only by a company, used exclusively only by the organization, not by someone else. Managed by the same company or by the third party. It is more secured, yes, because only my company is using this cloud. Centralized control, because everything is controlled by my company only, but weak service. Look, my company is into some particular business of manufacturing, say, then my employees are all expert in handling my business. They might not be expert in handling the cloud, handling the data centers and all. So whenever there is a problem, it will be more difficult for my company to tackle that problem. Instead, if I had been using Google data center for my data, then Google is expert in maintaining data center. So they will be definitely ensuring better service to the company. Yeah. So in case of private cloud, there is weak service agreements, as the service is between organization and the user of the same organization. They will feel that ki apna ghar ka hi hai, so they might not be interested in giving better service. But when you tell Google to give that service, they will definitely give you better service because they are into this business. They are only into this business. Yeah. So advantages of private cloud, it is improves your server utilization, more security, more controlled, but you have to invest very much more in that case. That is private cloud. Public cloud is used by general public. For example, Google created a data center and Google is giving space on this data center to other companies on rent. So if SBI is using Google data center, then Google data center becomes a public cloud, where SBI will pay money to use that Google data center. Yeah. So public cloud is open for use by general public, but it is on pay per use basis. Public has to pay in order to use that cloud. Done. That was your public cloud. Characteristics of public cloud. It is Highly scalable, meaning you can expand, you can ask Google to give you more storage space whenever needed. Affordable because you pay only for what you use. Less secure because others are also using the same cloud. Highly available, you can access it from any place, any location. And very stringent service agreements because it is a matter of business reputation for Google in that case. Accordingly, advantages, limitations you can see. Hybrid cloud means that a company has its own private cloud. Initially, it has only the private cloud, but later for extra space or extra resources, they will use the public cloud. Say I have my own data center of 10 million GB, but after a few years, if I need 2 million GB extra, then just for 2 million GB, I will not create a separate data center. Rather, I will store 10 million GB in my own data center and another 2 million GB in Google data center. Then now my storage becomes a hybrid cloud because it is partly private, partly public. Yeah. That becomes my hybrid cloud. Some storage is in your private cloud, some storage is in the public cloud. That makes it my hybrid. And under that, it will have characteristics, advantages, disadvantages, combination of all. Community cloud. If SBI wants to create its own data center, it might become costly. What SBI does is SBI will talk to ICICI, HDFC, IDBI, and these 4 banking companies come together and create their own data center. Now, if 4 banking companies come together and create their own data center, meaning now this data center becomes a community cloud. It is a cloud created by a specific community of consumers, and it will be created by them, managed by them, or managed by a third party. Yeah, that becomes your community cloud. Further, the most important thing under cloud computing was the different service models of cloud computing. 3 main examples of service model here: infrastructure as a service, platform as a service, software as a service. I said that cloud computing means services provided on the internet, various services ready-made on the internet. Now, what services can it be? It can be these kinds of services. One by one, each of them, I'll give you a short recap of them. Dekho. Infrastructure as a service. Just a moment. The first one, infrastructure as a service. IaaS, infrastructure as a service, meaning cloud providing me hardware infrastructure. Cloud computing that provides me hardware infrastructure, hardware such as processing power, storage, or any such hardware provided on the internet becomes infrastructure as a service, so that you can use the hardware without having to own or manage your own hardware. Within infrastructure as a service, different examples we learned here, like network as a service. Network as a service is also cloud computing. Why? Because VPN, remember lease line versus VPN. In case of VPN, I don't need to create my own cable here. Rather, I can use the internet for my connection. That is networking as a service. Networking as a service. Storage as a service. Storage on the internet, that is Google Drive pe store karo, that is storage on the internet. Database as a service. Well, many clouds provide me ready-made database. They provide me database like say Google Maps data. Google Maps is a database which is provided to many other software developers. Well, of course, that will be through API. For example, if say Ola cabs, Uber cabs, Swiggy, Zomato, all of them are using Google Maps. Now, if 4 different apps are using the same database, remember it needs an API in between. Remember, at all places where this word API comes, it has the almost same kind of meaning. I'll remind you. First, we had API when I talked about operating system. 4 softwares want to access same CPU, it needs API in between. Second, we had API just recently when we talked about a 3-tier architecture. 3 softwares in the application server want to access the same database in the database server, then again API is needed. Similarly here, 3 different softwares or 4 different softwares like Ola, Uber, Swiggy, Zomato, if these 4 softwares want to access the same server, or want to access the same database of Google Maps, if all 4 of them want to access same Google Maps, then Google Map should provide API, because none of the software developer need to know that how does Google store map data. They just need to know what is the Google Maps ka API. Yeah. So Google is providing database as a service in the form of maps, and for that they are providing API also, so that other softwares can access the Google Maps data. Backend as a service is used by app developers to store their software development data and all. And desktop as a service is basically providing desktop on the internet, so that I can get my same desktop from anywhere on the internet. I can access my same desktop just by logging in into my account. I will see my desktop on any computer. That was desktop as a service. Next, platform as a service was again for the software developers. It is a service to develop and deploy application. Application means software. To develop software. Now it is not my job, your job to develop a software. Who develops the software? Programmer. Programmers can use platform as a service to do the software development on the platform. Platform as a service changes application development from local machine to online. So instead of creating software on their own computer, they will create software on the platform. That is platform as a service. This platform provides various facilities for creating programs, facilities like programming languages, application ready-made frameworks, databases. It will provide testing tools, it will provide, so that it is easier for the software developer to create the software. That is platform as a service. And the last one, software as a service, was very important. Software as a service means to access applications over the internet, meaning software available on the internet. You have software on the internet which you can use even without installing. Yes, the software on the internet which you can use the software on the internet directly on the internet without even installing the software. That was your software as a service. Example, testing softwares like Ookla speed test. Speed testing softwares will test your internet speed directly on the internet. Or API as a service, like in case of that Google Maps example, Google Maps was database on the internet, but to use that Google Map, API provided is software on the internet. API provided is software on the internet. Same example, Ola, Uber, Swiggy, Zomato I had given you. Email as a service, providing email services on the internet. Other cloud service models. Communication as a service, like communication, WhatsApp calls, video calls and all you do. Data as a service, providing simple data on the internet. Security as a service. Example again, Google. Google provides say virus scanning on the internet directly. When you receive an attachment in your email, before you download the attachment, Google will scan for viruses. Where is the antivirus? On the internet. That is security on the internet. Identity as a service. When you file your income tax returns, then IT department wants to check your identity. They will check your identity through the Aadhaar network. You'll get an OTP from your Aadhaar website, and that Aadhaar website through they will do the identification. That is identification through the internet. That is authentication infrastructure by third-party service provider. So Aadhaar services is identification on the internet in that case. Yeah. Anyways, that was all about cloud computing. Next one, mobile computing is just like cloud computing. I'm not revising. It is all the things of cloud computing from the mobile phone, directly accessible from the mobile phone. That was mobile computing. Okay, and the remaining things in that emerging technologies were simple topics. I'm not giving detailed revision for that. Green computing was what? Green computing was practice of using computers and IT resources in more environment friendly way. And under that there were given various green computing practices. Practices were suggestions regarding how to use computers by not damaging the environment. Simple suggestions were given that you can read now again. Next, BYOD, bring your own device. This was a concept where companies have started telling the employees to bring their own devices for the company work. Benefits of that was that happy employees, so that employees are working on their own laptop, so that they will be more convenient. They will find working on their own laptop more convenient. Plus, good for the company because company can save cost. So lower IT budgets, company will save costs because they will tell you to use your own devices, own laptop, own mobile. Employees will also be happy because they love to use their own devices. Plus, company might even share the cost of the usage with the employees. Plus, because of that, the employees can work beyond their required hours. You can work at your home because you're working on your own device. IT department does not need to provide end user support. Yes, employees will be more proactive in adoption of new technologies. Yes, and efficiency of employee is more when he is using his own device. These were the advantages of BYOD, but also risk, that is threat of BYOD. Threat, network risk, device visibility is a risk. Why? Because if employees are using their own device, it might not be permanently connected to the company network. Look, if the company has given you a laptop, then the company would expect that your laptop should be connected always. But if you are using your own personal device for company work, company cannot expect you to keep it always connected. Maybe you're on a vacation, you're on a holiday, you have taken your mobile phone on your holiday, but company does not expect you to log in from there. Yes, so at that time, if the device is not connected to the company network, then it will lack device visibility. What is device visibility? Device visibility means that the company server does not see your device. If it is your personal device, then the company server might not see your device permanently. So if today the company server conducted a virus scan, then virus scanning was done for all the devices which were connected to the server. Your device not connected would miss out the virus scan. Yeah, that is network risk. Device risk, if your device is stolen, then risk is to the company because company data is there in your device. Application risk, like you might not have proper antivirus or security software in your device. You might be downloading so many unnecessary apps on your devices, because of which there is application risk or risk of virus and malwares on your device. Risk is to the company ultimately. Implementation risk, company should have a BYOD policy. If your company is practicing BYOD, they should have a proper policy regarding BYOD, policy which will communicate the employees, the expectations of the employees. It will communicate that what is expected from the employee. You need to communicate clearly to the employee that what is expected from them, how are they supposed to use the devices and all. But if that is not clearly communicated, then it is a weak BYOD policy. Yeah. Then next is Web 3.0. It was an advanced concept. It is talking about something called as Semantic Web, in which it is a network where the computers will generate raw data on their own without any user intervention. Computers will generate data on their own. It will consolidate dynamic web contents depending on the interest of the individual user, also using artificial intelligence in that. It will consolidate the dynamic web contents. Look, internet contains lots of data about you. Semantic web will consolidate all your data from the internet to give you better services, to give you better advertisements, yes, to give you better answers to your questions and all that comes under Web 3.0. Semantic web is basically a common framework to share and reuse data across various applications, okay, so that the machines can take decisions on their own. Web services is computer to computer interaction. One computer can automatically interact with other computers on its own. Now the next version of Web 3.0 is Web 4.0. It is just little more advanced. It is proactive. It is content exploring, self-learning, content generating agents. These are certain keywords that should come in your answer. As such, I don't see much difference between Web 3.0 and Web 4.0. It is just that it is little more advanced. Yeah. Next, Internet of Things. Oops, just a moment. Internet of Things is basically talking about things having internet connection. Things, look, generally computers have internet connection, but in case of Internet of Things, it says objects, things having internet connection, things having ability to transfer data over the network. Now under this part, what we had mainly learned was examples. Under this, what we were supposed to mainly learn is various examples of devices, things having internet connection. Many examples we had talked about. Some examples I'll remind you again, like machines, washing machines having Wi-Fi connection, water purifier having Wi-Fi connection, home appliances like smart TVs and all connected to the internet, office machines also connected to the internet like vending machines, Wi-Fi printers are also nowadays there. Body implants having internet connections, wearables, smartwatch and all, smart city, smart grids. For that. Smart city is the initiatives that the government are now planning, where water distribution, traffic management, waste management, everything will be through the internet. Smart grids is basically electricity distribution also managed through the internet, so that they can keep a track that who is consuming how much electricity and all. Industrial Internet of Things used in industries by connecting machines and devices in industries and all. Connected car, automated car connected to the internet, and all these other examples. Okay? But under IoT, you need to also learn risk of Internet of Things, risk to the product manufacturers. Because of IoT, your routine product manufacturers, some of the product manufacturers, routine product manufacturers will go out of business. Because they are manufacturing routine products. Plus there is huge amount of data, so much data is there collected from the IoT devices, so the server needs to ensure that these data is kept secure. That is a risk. Risk to the user has the risk that if my devices have internet connection now, then these devices are also now subject to hacking and virus. Imagine, until now we have virus and hackers in laptops, desktops, mobile phones. There might come a time later when even TV will have virus. Smart TV start having viruses. If the television has internet connection, then it might also have virus. ACs might have virus. Washing machine might have virus. You might have never thought of that, but maybe someday in future that might happen because they are having internet connection. Privacy. If all these devices have internet connection, means all these devices have data, and my privacy might be at a risk. My privacy might be at a risk that if the company server is hacked, if my AC has internet connection and if the AC company ka server is hacked, then the hacker might come to know my AC usage and all. Yeah, that is again privacy risk is there. And risk of obsolescence of devices. Whenever new product will come, then old products will become obsolete. It will force the user to dump the old products. When Apple launches new version of iPhone, then maybe in that new iPhone the charging cable is different. It will force the user to dump the old charger. Yeah, that is like intentional obsolescence of devices. Technology risk, lack of technical standards, because in case of mobiles and laptops there is a standard operating system, but in case of these other devices there is no standard operating system. So every TV which is a smart TV will need a separate app development. App developers, software developers will have to separately develop apps for each of the smart devices. This makes the task of developing applications very tough. Environment risks. If devices start having internet, then more environmental damages will happen. Impact of house air quality due to earth metals, heavy metals used in the technologies. Plus, if all devices start having internet connection, then there is more transmissions, more radiations in the atmosphere and all that is the environment risk here. And lastly, artificial intelligence was the ability to use memory, knowledge, experience, understanding, etc. by the computer to solve problems and adapt to new situations. This was the definition. In general, I said that artificial intelligence means computers having human abilities of human-like abilities. Generally, computers are supposed to follow instructions. But artificial intelligence means that computers have human-like abilities to use memory, to use knowledge, experience, understanding, reasoning, imagination, etc. Judgment to solve problems. They can solve problems on their own. They can even adapt to new situations. I did not program the computer for that. Still, they can adapt to new situations. That is artificial intelligence. Various examples we had discussed about artificial intelligence. Either you read these examples or you make your own examples. Anything will be fine. Risk. Well, artificial intelligence has various risks that it relies heavily on data. Incorrect data might lead to incorrect conclusions. Security threat. Robots carry a security threat. You have seen various movies about robots, that robots will finally try to kill robots will finally try to kill humans and take over the human race. That is like a kind of security threat. Plus, in the long term, because of robots, it will kill human skills of thinking the unthinkable. In other words, you become dependent on the artificial intelligence so much that you don't want to do things on your own. It is done by the artificial intelligence. Yeah. Another type of artificial learning is machine learning. Machine learning is basically a type of artificial intelligence. It is almost the same thing, ability to learn without being explicitly programmed. The machine will learn on its own. It doesn't need to be programmed. Yeah, like image, video, text recognition, recommendation. YouTube recommends video to you based on what types of videos you watch. That is why, because YouTube will learn based on what types of videos you watch, and accordingly that will be suggesting videos to you. That is also a kind of machine learning. Anyways, so that covers the last topic here, artificial intelligence and machine learning. That completes my chapter number 4. This was my lecture number 2, revising chapter number 4. Thanks. That's all. Thank you very much. Next lecture will be revising chapter number 1. That will be my lecture number 3. We'll be revising chapter number 1. That's all for now. Thank you very much.